Okay, so this is a problem that I found on the internet when I googled cool examples of L'Hopital's rule, and I chose it because it was the first one I found that had an interesting trick that we hadn't covered in class. So when you solve this and find the limit, you get 1 over 1 minus 1 minus 1 over the ln of 1, which gives you 1 over 0 minus 1 over 0. Which isn't one of the indeterminate forms that we talked about, so we can't use L'Hopital's rule. However, if you find the common denominator of the two fractions and add them together, and then you simplify the lim as x approaches 1 of x ln x minus x plus 1 over x minus 1 times the ln of x, you find that this equals 0 over 0, which is an indeterminate form, so we can apply L'Hopital's rule. So we take the limit as x approaches 1 of x ln x minus x plus 1 over x minus 1 times the ln of x, and apply L'Hopital's rule. So we use the chain rule to get the derivative of the top, so it'll be the limit as x approaches 1 of the first, x, times the derivative of the second, 1 over x, plus the first, the derivative of the first, which is 1, times the second, ln of x, and then this will be minus 1 for the derivative of x. All that over another chain rule, the derivative of the first, 1, times the second, ln of x, plus the derivative of the second, 1 over x, times the first, x minus 1, and then we simplify that. Then the 1's cancel, and we're left with the limit as x approaches 1 of ln of x over ln of x plus x minus 1 over x. When we take that, we still get 0 over 0. So we can apply L'Hopital's rule one more time. Now when we write it to prepare to take L'Hopital's rule one more time, we write that x minus 1 over x, this bit right here, as 1 minus 1 over x to make our job a little bit easier. We take L'Hopital's rule, the limit as x approaches 1 of the derivative of the top, which is 1 over x, over the derivative of the bottom. So 1 over x plus 1 over x squared. And now when we plug in 1, we get 1 over 1 over 1 over 1 plus 1 over 1 squared, which equals 1 over 1 plus 1, which is 1/2.